This paper addresses a key limitation in how language models use tools. Current approaches either require fine-tuning models on specific tools, limiting them to only tools seen during training, or stuff tool demonstrations into prompts, which becomes inefficient with many tools. The authors introduce Chain of Tools, which leverages the semantic understanding of frozen language models to dynamically select and use tools during reasoning, even if those tools weren't seen in training data. This approach maintains the model's reasoning abilities while expanding its tool use capabilities to include new, unseen tools. Figure 1 illustrates the ideal tool calling procedure that Chain of Tools implements. When a user asks about tomorrow's weather at their destination, the system first needs to determine what that destination is. The model generates text tokens, and at certain points, the tool judge decides if a tool should be called. The system first calls the schedule tool to find the user is attending an NLP conference in Shanghai, then calls the weather tool to get the forecast. This demonstrates how the system can perform multi-step reasoning, calling different tools in sequence to build a complete answer. Section 3 explains the methodology behind Chain of Tools, which consists of 3 main components. The tool judge analyzes the hidden state of each token as the model generates text, deciding if a tool should be called at that point. If needed, the tool retriever computes query vectors and tool vectors to select the most appropriate tool from the available pool. Finally, the tool calling component uses in-context learning to determine tool parameters, execute the tool, and incorporate its output into the answer. Importantly, all this happens while keeping the foundation model frozen, preserving its reasoning capabilities. Figure 2 provides a detailed overview of the Chain of Tools method. The process starts with QOT reasoning, where the foundation model generates answer tokens step by step. The tool judge monitors each token to decide if a tool should be called. When needed, the tool retriever creates vector representations of both the query and available tools to find the best match. The tool calling component then executes the selected tool with appropriate parameters and integrates the result back into the answer. The whole system is designed to be flexible, allowing tools to be added or removed from the tool database without retraining the model. Section 4 presents experimental results across 4 different datasets, covering both numerical reasoning and knowledge-based question answering tasks. Chain of Tools consistently outperformed baseline methods, particularly in challenging scenarios with large tool pools, 1,000 plus tools, and when handling completely unseen tools. The method worked surprisingly well, even with lower quality training data, suggesting its contrastive learning approach helps the model learn to distinguish between tools effectively. The researchers also discovered that specific dimensions in the model's hidden states play a crucial role in tool selection, providing insights into how language models represent tool-related information. The paper presents a significant contribution to tool learning by enabling frozen language models to effectively use large numbers of tools, including ones they've never seen before. The approach preserves the model's reasoning capabilities while adding flexible tool use without expensive retraining. The authors also contributed a new evaluation dataset with over 1,800 tools. However, they acknowledge limitations. Current datasets are relatively simple, and the method needs testing with more complex tools that return multiple values. Future work could integrate this approach with more advanced reasoning techniques like tree of thoughts.